picture below to the right is function g of x. So this is g of x. I'm actually just going to write that in. This is g of x. And now we're going to graph this off to the left, and this will be my p of x. So this is going to be function p of x. Now, what is the parent function? The parent function of this is y equals the square root of x. And that's going to help me in graphing this. So what's the smallest number that we can plug into a square root function? That would be 0. Square root of 0 is 0, square root of 1 is 1. And again, can we take the square root of 2 and the square root of 3? Yes, but they give us irrational output values. So I'm going to stick by plugging in perfect squares like 1, 4, 9, 16, and so on. Square root of 4 is 2, square root of 9 is 3. Alright. Now, this says we're going to move to the right 3 and down 4. Let's do that together. Right 3 and down 4. Think of that as your 0, 0. Now, what I have not talked about so far is this 2. What does 2 do? 2 impacts the output values. It allows us to stretch this graph at a faster rate. So, 0 times 2 is still 0, 1 times 2 is 2, 2 times 2 is 4, and 6. And now, this is 0, 0. I go to the right 1 and up 2, right 1 and up 2. I go right 4 and up 4, and I go right 9. Well, 3 plus 9 is way out here, and I'm going to go up 6. Something like this. Now, it may be helpful because we're going to have to answer a question. It may be helpful for us to do it on this exact same graph. And I think I'm going to do that because I know down below I need to answer some specific questions. So I'm going to go over 3, 1, 2, 3, and down 4. Right, right there it is. And then up 1, up 2, there's 1 point. And then I'm going to go over 4, right here, and up 4. Oh, right there. Oh, hold on here. I think that my numbers were initially off. Let me grab a Kleenex really quick. Let me grab something. I think my initial numbers are probably graphed, but I'm going to use a different color here because I think that I was off by 1 place value here. It's so light. I went over 3, which is right here, 1, 2, 3, and down 4. That should have been right here instead. That makes a difference. And that's my 0, 0. Now I go over 1 and up 2, which is right here. And from here I go over 4, which is up here, and up 4. And then over 9, which is way out here, and up 6. And there's our square root function. So I have both p of x and g of x on the same graph. Okay, please go ahead, and I want you to state the domain and the range for g of x. Go ahead. The domain goes from -8. And if you walk along this bridge, you can look down, look up, even here at +1, although there's a hole in the graph above, down below there is an output, all the way to +6. And I include those points. Now the range, it goes as low as a -4, and as I look up, it goes as high as +2, but at 2 there's a hole in the graph. For those in front of me, do you guys agree? Okay, let's go down to the next part. Sorry, my allergies are really bad. State how the graph of the function p of x would be different from the graph of the parent function. Alright, and then it says to graph it. So we've already graphed it, but how is it different? Well, here's how it's been translated. We've taken the parent function and we've moved it to the right 3. Now you're going to have to be able to say this in words on the test. So if you're not doing it now, I would definitely say it in words now on your paper. We're going to translate it or shift it, you could say, to the right 3 and shift it down 4. And how do we say this? This is vertically stretch it by a factor of 2. The order you state these does not matter. So horizontally you're shifting it to the right 3, vertically you're shifting it down 4, and then even just saying moving it to the right 3 and down 4 would suffice. But this is important. You're vertically stretching it by a factor of 2. Let's go to part C. State what would be graphically true if p of x equals g of x. So if that's true, that means the two functions intersect. Now remember, I graphed this wrong, so we're looking at the pink. Do my two functions that I see graph both in P of X and G of X ever cross? Nope, so they never cross. But if this was true, they would cross. And so for how many X values do they cross? 0. They never cross. All right, now let's try this next one. So we are going to do this algebraically. I'm going to have you do the same here before we get started. So we're going to go to function P, which we have an equation for, and we're going to plug in 12 and get an output value. 12 minus 3 is 9. The square root of 9 is 3. 2 times 3 is 6, and 6 minus 4 is 2. So the output value when I plug 12 in for P is 2. Now, G of X, we don't have an actual equation, but we have a graph. This says go to where X equals negative 4, and let's figure out what is going to be the output. So let's go to negative 4. Here's negative 4, and at negative 4, the output, the Y value, is 0. Why can I stop right now? Why do I not have to take time to figure out G of 5? 0. 2 times 0 times whatever this is 0. So this is all 0. So I'm only left with 2 inside. 2 times 3 is 6. This entire thing equals 6.